Okay, we're still looking at coat colors in mice, and let's see what we have this time. This mouse has this parent has the colored trait, and the color it produces will be black. This mouse is colorless, and if it did produce a color, it would be tan. That's the recessive bees, but they have the recessive albino allele, which means don't produce pigment at all. So, if we cross these, here we have, this one's heterozygous for both traits, meaning we can use FOIL to find the alleles, which will be big C, big B, big C, little c, big B, and little c, little b. And this parent is nice and simple. The only gamete they're capable of producing is little c, little b. That's all they have. So if we make a Punnett chart out of that, I'll go vertical this time for no particular reason. We have little c, little b from one parent, and then these things down the side. When you're really slick at Punnett charts, you don't even really need to write the gametes like this. You could just immediately set up your Punnett and then work these out and write them in the same place. You don't have to copy this and then copy it again. That will save you a few seconds. Okay, so what kind of baby mice do we get here? Big C, little c, big B, little b, big C, little c, little b, little b, little c, big B, little b, and little c, little c, little b, little b. So, what does that give us for phenotypes? This mouse is colored, and what color? Black, it's the dominant. So, black mouse. Colored tan mouse. The recessive color little b gives you tan. Little c means albino. We don't even have to look at this. Or if we do look at this, it tells us if only this mouse produced pigment, that pigment would be black. But little c says, nope, no pigment for you. You are an albino mouse. And here, this mouse would produce tan pigment if only it could, but it's an albino also. So when you see little c, the color is irrelevant to how it looks. So genotypic ratio would be, I'm just looking for duplicates here. There are no duplicates, so it would be one heterozygous for both, one hetero C homorecessive B, one homorecessive C hetero B, and one double recessive. Or if you're doing phenotypes, you'd have one black to one tan to 2 albino. And you can't reduce that because you can't divide 1 by anything, so this ratio is as low as it's going to get. Anytime there are 4 mice, you would expect roughly to get one of them to be black, one tan, two of them, half of them, or 2 of them to be albino. If you wanted percentages for something like this, there are a total of 4 mice that we're talking about here, 1 plus 1 plus 2. And so you divide all of these numbers by 4, and you'd get a probability of 0.25 for black. 1 divided by 4 again gives you 0.25 for tan. And 2 divided by 4 gives you 0.5 for albino. And if you multiplied all those by 100, you could say 25% black mice, 25% tan mice, and 50% albino mice.